Welcome back to DG Tutorials and to the fascinating world of radicals. Today we're diving deep into multiplying and dividing square root radicals, an essential skill for grade 11 math and beyond. Don't worry, we'll break it down step by step, making it easy to understand and apply. Radicals, denoted by the symbol, are used to find the root of a number. For example, 9 asks, what number, multiplied by itself, equals 9? The answer is 3, making 9 equal to 3. Understanding this basic concept is key to mastering the operations we'll explore today. We'll uncover the patterns and rules that govern these operations. Get ready to simplify expressions and solve problems with confidence. Let's get started. Let's start by multiplying radicals. Take a look at this example, 2 times 8. At first glance it might seem a bit tricky, but there's a simple pattern that makes it a breeze. We can rewrite this expression as 2 times 8, combining the numbers under one radical sign. This becomes 16, which we know equals 4. See? Not so intimidating after all. Let's try another one, 5 times 3. Following the same pattern, we get 5 times 3, which simplifies to 15. This time we can't simplify further, so we leave it as 15. The pattern we just observed is formally known as the product law of radicals. This law states that for any non-negative numbers a and b, the square root of their product, a times b, is equal to the product of their individual square roots. In simpler terms, a times b equals a times b. This law holds true even when dealing with variables. Understanding the product law is crucial for simplifying expressions and solving equations involving radicals. It allows us to break down complex problems into smaller, more manageable parts. Let's solidify our understanding with a few more examples. Example 1. 6 times 3 equals 18. We can further simplify 18 by factoring out a perfect square, 9 times 2 equals 9 times 2 equals 32. Example 2. 10 times 2 equals 10 times 2 equals 20. Simplifying further, 20 becomes 4 times 5 equals 4 times 5 equals 25. Remember, the key is to look for perfect square factors within the radical to simplify the expression as much as possible. Practice makes perfect. Section 5. Dividing radicals, simplifying expressions. Now, let's explore the division of radicals. Similar to multiplication, there's a specific rule that governs this operation known as the quotient law of radicals. This law states, the square root of a divided by b is equal to the square root of a divided by the square root of b, where a and b are non-negative numbers, and b is not 0. This means we can simplify the square root of a fraction by taking the square root of the numerator and the denominator separately. Let's see this in action. Section 6. Quotient law in action examples. Consider the expression the square root of 16 divided by 4. Applying the quotient law, we get the square root of 16 divided by the square root of 4. The square root of 16 is 4, and the square root of 4 is 2. Therefore, 4 divided by 2 equals 2. The quotient law simplifies expressions involving radicals. Section 7. Exponents and radicals. Two sides of the same coin. You might be surprised to learn that exponents and radicals are closely related. In fact, they are two different ways of expressing the same mathematical concept. For instance, the square root of a number can be represented as that number raised to the power of 1/2. In other words, the square root of a equals a to the power of 1/2. This connection opens up a whole new world of possibilities for simplifying expressions and solving equations. Understanding this relationship is essential for tackling more advanced mathematical concepts. Section 8. Rational exponents in the real world. Calculating compound interest. Rational exponents have real-world applications, particularly in finance. One such application is calculating compound interest. Deposit $1,000 at 5% interest compounded annually. Use the formula A equals sign P, 1 plus Rn, NT. Here, A is the final amount, P is the principal, R is the interest rate. Plugging in values, A equals sign 1,000, 1 plus 0.05 cubed. This simplifies to 1,000, 1.157. After 3 years you'll have approximately $1,157.63. Section 9. Keep exploring. The adventure continues. Congratulations, you've successfully navigated the world of multiplying and dividing radicals. You've learned the product and quotient laws, explored the connection between exponents and radicals, and even witnessed the real-world application of rational exponents. Remember, practice is key to mastering these concepts. Don't be afraid to tackle more challenging problems and explore further. If you have any questions, don't hesitate to ask your teacher or classmates. The journey of mathematical discovery is ongoing and there's always more to learn.